Good morning, everyone. My name is Faizal Abdurahman, and now I want to present my research. And the title is Flexural Reinforcement of Lamiancy-Concrete Camphor Composite Bridge Structural Element using plain reinforcement steel butt and anchor. Okay, next. Here the abstract. Wood has string-edge properties, so it affects the availability of the maximum dimension of wood available in the market. To meet the need for dimensions that are larger than the maximum dimension available in the market, laminated bar and beam are made. Dimension of thickness and height and length of laminated wood beam can be made according to needs, so that the thickness and height and length dimension can be much more than the maximum dimension of the beam on the market, thus worthy of being used as main beam or sub-beams of a bridge. To overcome this, the laminated wood beam are composited with reinforced concrete slabs so that they become a composite of laminated wood beams, reinforced concrete slabs. Reinforced concrete slabs serve as bridge floor as well as protective laminated timber beam to protect them from heat and rain. Wood has more elastic properties compared to reinforced concrete to overcome this. The part of the wood fibers that experience bending must be strengthened. The research method was carried out by testing the flexural testing of laminated Camphor composite beam reinforcing concrete slabs reinforced using a second plane reinforcing steel and are anchored using bolts. The variable used include the amount of reinforcement, namely 1, 2, and 3 plane reinforcing steel bars with a diameter of 8 mm as well as reinforced beam as a control beams. Okay, next. Formulation of the problem. First, what is the flexural strength of laminated Camphor composite beam reinforced concrete slab if it's not reinforced with plate reinforcing steel? Second, how much is increase the flexural strength in the laminated Camphor composite beam reinforced concrete slab with reinforcement consisting one control beam with one reinforcing bar, two reinforcing bar, and the last is three reinforcing bar. And the third, what is the failure model for the laminated Camphor composite beam reinforced concrete slab reinforced using plain reinforcing steel? And the research purpose is to analyze the stiffness of the flexural reinforcement on the structural element of the laminated concrete Camphor composite bridge using plain reinforcing steel anchored at both ends. And then, analyzing the ductility of the flexural reinforcement in the structural element of the laminated concrete Camphor composite bridge using plain reinforcing steel but anchored at both ends. The scope. First, the tests carried out are in the form of preliminary tests, namely testing of the character of the wood, steel, and concrete composite materials, followed by testing the composite beam in the form of flexural tests, while the reinforcement used is plain reinforcing steel with a quality of 240 MPa and anchors. Second, the material used is the concrete quality Fg prime 22 MPa, reinforcing steel with a quality Fy of 240 MPa, and the type of wood used is Camphor wood. Here all research about the laminated wood and the steel anchor. Literature review, first from Giovanni Metelli. His research is the repair of timber beam with controlled debonding steel plates. The study examined the flexural reinforcement using epoxy resin and steel plates on wooden building beam structure that are damaged due to the loss of moisture in the wood. And then Thomas Nowak et al. At 2016. The title of the research is The Strength and Tension of Timber Beam Using Steel Plates Review and the Experimental Test. In this study, two test beams were used. The first test beam is reinforced in the flexural section by means of the nailed steel plate, and the second test beam was reinforced in the flexural part by using a steel plate which was nailed and smeared with adhesive at a junction of the steel plate surface and the wood surface. Next, from T.M. Wicaksono et al. 2018, research title is Analysis of the Flexural Reinforcement of Single Wood Laminated Beams Screwing with Laminated Composite using Steel Plate. The purpose of this research analyzed the flexural of composite beam from weak wood sengon for the inside by using engineering in the compression section using a laminated of strong wood screwing and the tensile section mounted by steel plate as a flexural reinforcement. And the last is from Kendariar and Fajar DI. At 2018, the title of research is Analysis of the Compression of Wood Steel Laminated Composite based on SND 7973 2013. Next, the methodology start. We try to review. Next, here the figure from the beams we made and the object test using testing material UTM, load cell working, LVDT, and the last data logger function. Here the analysis of reinforced wood concrete composite beam. For the composite beam structure data is prototype. I choose the composite beam length 6,000 millimeter. Concrete quality FC prime 22 MPa. Steel quality FY 240 MPa. So the geometric scale is a useful analyzing is the concrete width BA 250, wood width 100, beam height 200. Concrete height 80, wood height 120 millimeter, beam length and 1,500. The first is I wanna make the balance of style determined for force balance. It takes several variables that needs to be calculated, namely the transversion factor, cross-sectional area, neutral line to the lower side, neutral line to the upper side, moment of inertia, upper flexural stress, lower flexural stress, compressive force on concrete, the compressive force of the reinforcement, the yield capacity of the reinforcement, the compressive force of the wood, and the tensile force of the wood. So that's 12 steps which to determining the balance of style. So here is it. First, the control beam determining balance style is each of the beam have several and different moment capacity, and the control beam is 1.764.13 kilonewton millimeter, and the axial capacity is 31.16 kilonewton. The one reinforced, the moment capacity is 15999.65 kilonewton millimeter, and the axial capacity is 31.63 kilonewton. And the third is with the two reinforcement, and the capacity moment is 16270.50 kilonewton millimeter, and the axial capacity is 32.18 kilonewton. And the last is with three reinforcement, which has capacity moment is 16543.71 kilonewton millimeter, and axial capacity is 32.72 kilonewton. Next, determination composite bridge beam capacity. Is from the seeking the deflection. The maximum moment that occur in the middle 1/3 of the span is 1/3 PL at 1/3 of the middle of the span. The beam only experiences the pure bending without any influence from the latitude force. So the first is moment capacity, load, maximum load, which we assume is for deflection is 50 kilonewton. And the table is the resume of the test object ultimate moment we have, and the control beam with 1 reinforcement, 2 reinforcement, and 3 reinforcement. Based on the results from the table above, the addition of reinforcement still under the beam produces different the ultimate moment. The more reinforcement is added under the beam, the greater the ultimate moment. So this is the end. Thank you for watching, and good morning everyone.